We're going to do another simple series problem, but this time we have a mystery. And the mystery is we don't know what resistor 4 is. We know that the resistance total is 80 ohms, and we know that resistor 1 is 10 ohms, resistor 2 is 20 ohms, resistor 3 is 30 ohms. We don't know what resistor 4 is. Now we know from our 3x5 card that resistance total is the total of all the resistances, right? So let's write out that formula of what that says. That says RT, let me go back and change this font, sorry. RT is equal to, in this case, R1 plus R2 plus R3 plus R4. And we know that RT is 80. And we know that R1 is 10 ohms. And we know that R2 is 20 ohms. And R3 is 30 ohms. Well, we can rearrange this thing, right? We can take everything that's on the right side that's a number and subtract it from both sides, right? What is 20 plus 30 plus 10? 60. So we know that 80 is equal to 60 plus something. So we could just subtract 60 from both sides, and we know that 20 is R4. Okay? Now, of course, that's not enough. We're going to go back and plug everything in and find out what our voltage drop across each one is, right? But of course we are. And we're going to find our power totals and all that good stuff. So now let's do that, and let's find what is our current. Because what we need to know in any series circuit is what is our current. Our current, that's right, our current is 1.5 amps. So we can go around this thing the whole way and plug in 1.5 everywhere we have current, right? Because current is constant in a series circuit.
How do we get
We divide the voltage by the resistance to get 1.5. You look at your 3x5 card, and how do I get current? How do I get current? Look at your let him look at his 3x5 card. Okay. Okay, so now we figured out that R4 is 20 ohms. So we can plug that in now also. So let's start with our number 4 resistor and find our voltage drop. And all we need to do is, what is our formula for voltage? If we're looking at EIR, E is equal to I times R, right? So all we have to do is multiply up. Now, what are we going to be multiplying every time? 1.5. So let's put in your handy dandy TI 30 X2S calculator. Let's put in 1.5 first times 20, and we get a total of 30. So we're dropping 30 volts across there, right? Now, so now we're going to do the same thing. Now, if I've got a TI-30X2S, I can just arrow back over the 20 and put in, what is my resistance? 30. I can just change the 2 to a 3 and hit enter. And it's 45. So we're dropping 45 volts here. And now if I just arrow back over 30, I can put in 20 again. Well, we know that's 30 volts. We don't have to do that. And then we're going to go back to the first one, and I can figure out this one. 10 times 1.5 is going to be what? Now, what do we need to do? We need to do our cross check. So now we're going to come over here, and we're going to see if our voltage adds up to 120. So we're going to add up all our voltages. We're going to add up 30 plus 45 plus 30 plus 15, and we get a total of 120. Pure functional magic, I tell you. So we know that we're okay, right? So now if we just multiply our powers up, we'll get 1.5 times 30 is, what, 45? 45 watts, and then 1.4 times 45, and on around, and we just multiply our power up 1.5 times 120 to make sure that our powers add up correctly to avoid mistakes. Everybody clear on this? All right.